I've taken three questions from the chapter probability, and these questions are very similar. And the reason for taking three questions similar is because by the time you reach the last part, the concepts gets reinforced. So I'll begin with the first part here. Let's say if I read the first part. So what does the question says here? It says a card is numbered from 11 to 60 are kept in a box. If a card is drawn at random from the box, what we have to find out is the probability that the number on the card is, there are parts like odd number, perfect square, and so on. So first thing that we will do is the numbers that we have are from 11, starting from 11, say 11, 12, 13. Obviously, we'll not be writing all of them, 59, 60. Now, the first job is to find out how many numbers are there from 11 to 60. Not from 11 to 16, it is including 11 and 16. So the rule here is to first get the difference. And what is the difference of these two? It's coming how much? 60 minus 11 is how much? 49? Yeah, that should be 49. And since both 11 and 60 are included, are counted, and that's why we'll add 1 to this. So that is 50. So we have total of 50 cards, and then we have to find out the odd number. Now we won't go randomly that there are 50 cards, so therefore half of them will be odd. Not necessarily be, because you have to be you have to remember that the numbers are starting from what to what, right? That's the reason I said we need to be careful in this case. So I will apply like this from 11 to 20. 5 of them is odd. So similarly 21 to 30 will be 5, and I have to reach till 60, so I can say 5 into 5, that is 25. Well, in this case, it is true, half of them, but not necessarily in all cases. So we can say that how many odd numbers are there altogether? The odd numbers we have are how many? 25. And then we have to get the probability. And what's that we have to find out is the probability of getting an odd number. So if I use PA here, so you see that 25 is the favorable and total number of observation is 50. So that results to give you half. That's for the first part here. We got the answer for the first part. Now let's do the second one. Next question, it says a perfect square number. So we need to write in this case perfect square. What are the perfect square here? Remember, it's has to be greater than 11, not any perfect square or starting from 1. So 2 square is 4, 3 square is 9, 5 square is 16. 4 square is 16. So 16 is the first. Then 5 square 25, 6 square 36, 7 square 49, and 8 square is 64. That goes beyond 60. So we'll say that there are 4 of them. So if I get the second part, the probability of getting a perfect square number is 4 of them are favorable, and we have how many? 50. Total number of observation is 50. So it's 4 over 50. On reducing, you are going to get 2 over 25. Now check, we have to get the number which are divisible by 5. So since 10 is not considered, right? So be careful here that we have to find, actually we have to find out. So the first multiple after 11 is what? 15, right? 20, 25, 30, 35, 40, 45, 50, and 55, and then 60 also, right? Because 60 is included. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So probability for the C part is what? There are 10. 10 over 50. That comes out to be 1 over 5. That's what the answer for the third part, right? Now I'll do the last part over here. What does it says? A prime number less than 20. So less than 20, but has to be more than 11, or sorry, 11 or more than 11. Why? Because the cards are numbered from 11 to 60 and not 1 to 60. So the prime number, 1 is neither prime nor comp, sorry, 11 is a prime. We are starting from 11. The next prime is 13. After 13, 15 is not, 16 is not, 17 is prime, 18 is not, and 19 is prime. But then we have to take less than 20. So the required probability, let's say if I use PD over here, again, this is 4 favorable observation out of 50. On reducing, we are getting 2 over 25. Yeah, that's what. So same answer we got for the fourth and second part. Now, let's move to the next question. In the second question, he says a bag contains cards numbered from 1 to 49. A card is drawn at random from the bag after mixing the cards thoroughly. Find the probability that the number on the cards is an odd, a multiple of 5, perfect square, and even prime number. So similar to the previous question, here the cards is, but this time it is numbered from 1. So 1, 2, 3, and so on. We'll get like 47, 48, and 49. Right. So first part is what? An odd number. So here you can see, as you can see that, first of all, you will find the total, how many numbers are there. And what I told you is the range, that is 49 minus 1 will give you 48. And since both of them are included, so we'll add 1 to this. That means we have total of 49 of them. And how many of them are odd? Okay, here you cannot just divide half. You see that even starting with odd and ending with an odd, you may count it. So you'll get there are how many odd numbers? It should be half, 25 of them. So you may go like this. You can count till 1, 2, 1, 3, 5 like that. So anyway, we have to get the probability. This is an easier to count. So no need for a trick. Let's say odd is 25 and total is how much? 49, right? Is it 49? Yeah, because if it 1 and yeah, it should be 25 over 49. You can cross check it that we are include, like if you count from 1 to 5, there are 5 numbers including 1. And so if you are counting from 1 to 49, obviously there will be 49. So that's the answer for the first part. Then we have to get a multiple of 5. So multiple of 5 is what? So you may write this is 5, 10, 15, 20, 25, 30, 35, 40, 45, right? 50 is not there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So probability for the second part is 9 over 49. Checking for the next part, the third one over here, a perfect square. So what a perfect square here? 1 is should be included. 1 is a perfect square. 2 square is 4. 3 square is 9. 4 square 16. 5 square 25. 6 square 36. 7 square is also included. So it's 1, 2, 3, 4, 5, 6, 7. So in that case, it is 7 over 49. But this can be reduced. So 1 over 7 you should write in the exam. Okay. And next is, I'm on the next part, that is an even prime number. Well, universally there is only one even prime number, right? Even prime number is only 2. 2 is the only even prime number. So we'll say that the probability is what? The count is 1. The number is 2, but the count is 1. 1 out of 49. That should be the answer for this part. Let's do the next. What's the third question? Is a bag contains 25 cards numbered from 125. What we have to find out is the probability that the card drawn is number 1 divisible by 3 or 5, a perfect square number. Well, one part is different, therefore we should do it. Now, the number here is like 1, 2, 3, and so on. So like 23, 24, and 25. As usual, here also we will be finding the total numbers here. That should give you how much? 25. Because it's counting from 1 to 25 has to be 25. And then divisible by 3 or 5. That means we have to take the divisibility of 3 as well as, right? 5. So 3, then next, I'll say 5. Then like that, 6, 7, 8, 9. 9 is divisible. 10 is divisible by 5. 11, 12 is divisible by 13. 14 is not divisible. 15 is divisible by 5. 16, 17. Because it's or, not and or common multiple. right? It's a union of 15. 16 is not, 17, 18 is there by 3, 19, 20, 21 even, right? Back to back. 22 is not there, 23 is not there, 24 is by 3, and 25 is by 5. So you can see that you can figure out that we have taken multiples of 3. All multiples of 3 is taken here, 18, 21, 24, and similarly I've taken the multiples of 25, and the common multiples should be counted only once. 1, 2, 3, 4, right, 5. So anyway, this is easy to get even if you write. So we have to get the probability, and the required probability in this case, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is favorable and 25 is the total. So this is the answer. But the last part, as I can see, we have done earlier also, a perfect square. So 1 is a perfect square, 2 square is 4, 3 square is 9, 6 square, 4 square is 16, and 5 square, 25 is included because it is not between. So probability in the second part, how many of them? 1, 2, 3, 4, 5. 5 out of 25, but then it can be reduced. So I'll write the final answer as 1 over 5. Right, done.